Hello, welcome. In this video we are going to discuss an important property of the adjacency matrix of a given undirected graph, and that property is stated here. The adjacency matrix can be used to find the number of walks between two vertices in the undirected graph. The number of walks between two vertices in the undirected graph. And to explain this, let's consider a graph G and its adjacency matrix AG, A of G. The number of different walks of length K. See the number of different walks of length K connecting the vertex Vi to the vertex Vj. Here Vi and Vj are two vertices present in the graph. So the walks, number of different walks connecting the vertex Vi to the vertex Vj is equal to the ijth entry in the matrix A to the power of k, A raised to k. So what is A raised to k? It is A raised to k is the product of k copies of, it's the product of k copies of A, product of k copies of the matrix A. So it all that will all matrix will also be a square matrix because A is a square matrix. And symmetry will also be preserved for the matrix A raised to k. Let's consider this example. Example 1. In this example, we are considering the graph that contains 5 vertices. And this graph contains five vertices, and the vertices are numbered or labeled using the numbers 1 up to 5. 1, 2, 3, 4 and 5 are the labels. You can see the edges connecting the vertices, and using these edge connections and the vertices, considering these vertices and edge connections, we can prepare the adjacency matrix of the graph that is given the name capital A. And you can you can verify the values entered in the rows and columns in the matrix, and you can verify it, and yourself you can after verification you can get you can be satisfied yourself by verification. But important thing we are going to discuss is the way to obtain the number of paths, number of walks. If you want to calculate, suppose a question is asked to you, how many walks of length 3? How many walks of length 3 are there between the vertex 2 and the vertex 1? Or from the vertex 2 to the vertex 1, how many walks of length 3 are there? For obtaining the answer, for finding the answer, you can find an answer, find the answer to this question using a matrix, and that matrix is A cube. You must find A cube, that is A into A into A. 3 times you have to take A and then multiply 1 by 1 and to obtain A cube. After obtaining this square matrix A cube, you have entries in that in the matrix, and using these entries you can find the answer to the question. And that's illustrated here. So after multiplication you get the matrix. The answer matrix is, the matrix A cube is 3 6 1 5 5 6 2 3 6 2 and 1 3 0 1 2 5 6 1 4 5 and 5 2 2 5 2. The matrix in this matrix, and this matrix is symmetric. And this matrix you consider the 2-1 entry, 2-1 entry because you have to because we are considering the second vertex and the first vertex, or the first vertex and second vertex. The other way also you can take, because symmetry, the matrix is symmetric, and the order in which we consider the vertices doesn't affect the answer. The same answer will be there because of the symmetry of this matrix. And since we consider 2 and 1, the vertex 1, you can take the second row and the first column. You take the second row and the first column, then that entry is the entry in that at that position is 6. So the 6 is the answer to the question. But there is a different way you can find the same answer, and you can consider the first row and the second column. See the first row and second column, that way also you can find, there also you can see the same value 6. So 6 is the answer to the question that how many walks of length 3 are there from the vertex 2 to vertex 1, or from the vertex 1 to the vertex 2 in the graph. So that is 6. And therefore many such questions, many similar questions can be asked based on this matrix. The number of, but in all the cases you can find, if you are finding the answer to the question using a cube, using the matrix a cube, then all walks, all questions must be asked in which length must be fixed, that is 3. You can find the length of number of walks of having length 3 only using this matrix. So if you want to find the number of walks of length 2, you have to find a square. If you want to find number of walks of length 5, you have to find a raised to 5, that is a into a into a into a into a. So 5 times you have to take and multiply. So this way, with this variation, you can find the number of walks of length of a given length, of a specified length. Okay. So here the number of walks of length 3 from the vertex 1 to the vertex 3. See, from the vertex 1 to the vertex 3. The third column you have to consider. Since the entry is equal to 1, so 1 is the answer, the total number of walks of length 3. And the question, you see the question, how many walks of length 3 are there from the vertex 4 to the vertex 2? See, to get the answer, you can take the fourth row. Okay, you can take the fourth row and then the second column. In the fourth row, second column, you have to consider, and the number is 6. In a different way, you can one more different way you can find the answer. You have to consider the second row and the fourth column. You take the second row and the fourth column, because 4 2 or 2 4 both are same. The consideration of giving consideration to the order is not important here. So in the second row, the fourth column entry also you can take, that is 6, and you can see that both the values are same and the answer is 6. Okay, this is the way we can obtain the number of walks. Okay, thank you for listening.